Okay, so just looked at the idea of electric potential in components in series, and basically you can say that the potential difference of the supply is equal to the sum of the PD across the components. And this is for series. What about parallel then? If I get a lamp here, I know that's a 1.5 volts. That's a 0 volts. The potential difference across this is 1.5 volts. What happens if I put another one with it in series? Well, all of this is connected to this. There's no resistance between here, so all of this is going to stay at high potential, 1.5 volts pressure, if you will. All of this side is going to be connected with very little resistance, so that's going to be a 0 volts potential. And so straight away we see, well, basically, these two lamps are both going to have 1.5 volts across them, so they're going to each have the same potential as the supply. This is going to have 1.5 volts across it, this is going to have 1.5 volts across it. Same goes on here, put this on. This is going to have, all this will be 1.5 volts, all this will be 0 volts, so there's going to be 1.5 volts across it. So if things are in parallel, okay, the PD of the supply is equal to the PD of the components. Okay, not the sum of the components, but it's the PD of the individual. And that's the first thing we can look at. Okay, now we've got this, and we've got this idea, we can say, well, it's the same. What's going to happen to the current now? If we think about it, let's suppose we've got 1 amp, 1 coulomb charge flowing through this one because of the pressure difference, the potential difference. I'm going to draw this as a symbol out of there. Then, of course, this is the same situation. It's the same resistance. Remember we said that R equals V over I. So the current I equals V divided by R. So we've got 1 amp going through there. If this is the same resistance and it's got the same potential difference across it, it's going to have the same current going through it. So you can say there, okay, that's wicked. We've got 1 amp going through there. That draws 1 amp, 1 amp. And of course, logic tells us this is going to be 1 amp as well. I hope you see that. But if I've got 1 amp going through there, 1 amp going through there, and 1 amp going through there, surely I must have had 3 amps in here. There's my 3 amps. 1 goes that way, 2 amps go this way, then they branch off, 1 goes there, and 1 goes that way. So we see straight away, for things in parallel, what happens to the current? Well, the current of the supply is equal to the sum of the currents in parallel. So the currents in the supply is 3 amps going through the battery is equal to the sum of the currents in the components. So one word, components. But if we now think about what's the situation in a series circuit now, well, we just go back to very quickly go back to that original idea of things in series. Well, if I had, let's suppose I just had 1 amp there for 1 thing there. That's 1 amp in the lamp. That's 1 amp in the battery. If I put a second one in the resistor in the series, well, it's actually not going to be as much because basically we're going to have less potential difference across each one, so the current is going to be less. But let's just suppose let's say it's a half, and that's a half, so that's a half there, that's a half there. It doesn't matter how many lamps are put in. The more lamps are put in, the lower the current, but it's the same current going all the way around the circuit. Okay, it's the same amount of electricity going around the circuit, same amount of charge going around the circuit. So the series component, well, PD of the supply is the sum of the PD across the components, but the current in the supply, or in the supply I should say, is equal to the current in the components. So we've got this situation here. The current's the same in the components and in the supply in series, but the potential difference is shared out across the components. Whereas if they're in parallel, the PD is the same across the component, but the current is shared out across the component. And this is the fundamentals of circuits that we need to know. Okay, so I'll leave that at this stage. I'm going to look at circuits next time.